Good morning. This is our presentation on urban transport study in Kota Kinabalu, where we chose UMS campus. The team members are Muhammad Ikwan, myself Scott Suzuman Munang, Muhammad Nur Ikwan, Kertigan, and Aiman Daniel.
The study area that we choose is UMS campus. It is located in Kota Kinabalu, Sabah. It is known as high travel demand from students and staff. The peak congestion is during morning and late afternoon. The suitable case study is for urban transport issues. There are several critical issues that face in this area, which are traffic congestion during peak academic hours, inefficient public transport services, high parking demand and illegal parking, bus demand exceeds capacity, and long waiting times and overcrowding.
We chose two studies to be conducted in UMS campus. First is spot speed study from roundabout UMS to UMS gate, and second is parking demand and supply study in DKP Baru. For spot speed study, first we measured 100 meters off the road. We placed members from 10 meters from the finishing line. We identified the beginning and ending points. When the front bumper of the car crosses the starting line, we press the stopwatch. And as soon as the front bumper of the car passes the end line, we stop the stopwatch. We gather the data using a tablet. For parking study, we first obtain a parking lot layout for every space. We created observation sheets of 15 interval minutes. The number of occupied slots were counted and noted. After 2 hours, we determined the percentage of occupancy and calculated rate of turnover. And we determine when occupancy is at its highest, and we gather all the parking information. So this is the outcome of our spot speed study. As we can see, the speed range from 10 to 15, we got a frequency of 14. The speed range for 15 to 20, we got 58 frequency. 20 to 25 speed range, we got a frequency of 24. Speed range of 25 to 30, we got 4 frequency. And 30 to 35, we got 0 frequency. And this is the ogive that we created for cumulative speed distribution. For overall discussion, mean speed is 19 kilometer per hour. For the 18 percentile speed is 22.3 kilometers per hour. Majority vehicles are 15 to 20 kilometer per hour, and no vehicles exceed 30 kilometer per hour. This is our outcome for the parking demand and supply study. In the first minute, we get an occupancy rate of 42.6. In the 15 minutes, we get an occupancy rate of 51.5. In 30 minutes, we get an occupancy rate of 38.2. In 45 minutes, we get an occupancy rate of 58.8. In the 60 minutes, we get an occupancy rate of 45.6. And the last 15 minutes, we get an occupancy rate of 33.8. And as we can see, we have generated a histogram from the parking occupancy rate against time interval in DKP Baru. Overall, the peak occupancy rate at DKP Baru is 58.8 at 9:45 a.m. and the high parking turnover is 30 to 60 minutes. Overall, from these two studies, we conclude that traffic operates at LOSCD. It has a moderate flow but constrained flow. It also has high interaction between vehicles and pedestrians, and the parking behavior causes side friction.
For the short-term measures, the first one is to improve signage and speed control. The second one is zebra crossing and sidewalks. The third one is to implement smart parking guidance system. And the last one is to design a pick-up and drop-off zone. Next one, for the medium-term measures, we can use dedicated bus and e-hailing lanes. We can also use proper bus bays. The third one is to put up some real-time bus tracking, which is ITS. And the last one is to reduce interference with traffic. For the long-term solution, we can use BRT or campus shuttle corridor. We can also use smart parking and congestion pricing. The third one is to reduce private vehicle dependency. And the last one is to use sustainability campus mobility. So the expected outcome is we can reduce congestion and delays, improve public transport efficiency, enhance pedestrian safety, lower emission and noise, and last one is better overall campus mobility.
In conclusion, EMS faces peak hour transport challenges. Current system operates under pressure. Proposed phased solutions are effective, and we should support long-term sustainable transport planning. That is all from us. Thank you.